Welcome back to Zero Dark Emissions. Last time we left off with the installation of the onboard charger and DC to DC converter, and I said that this episode would show the functional testing of the EV systems, but somewhat as expected, I'm having some issues that I need to figure out, and while I'm sorting that out, I'm simultaneously handling the installation of the actuators, both at the front and rear, which I was going to handle next anyway. So I'll cover all of the issues that I'm encountering with the EV systems in the next episode, and we'll cover the actuators now. The actuators that I'm installing are for the park lock at the rear gearbox and the drive disconnect at the front motor and gearbox, both of which were discussed in previous episodes. I'll start with the simpler of the two, which is the rear park lock actuator. Here at the rear gearbox you can see the park lock, which just pushes in to lock when in park and pushes out to unlock when in drive or reverse. This prevents the gearbox and wheels from turning when in park. We will be placing an actuator between this lever on the gearbox and the chassis crossmember directly behind this, and the switching for this was covered in episode 9. Conveniently, we have this bolt that connects the diff mount to this crossmember, which is in just the right place for us to connect our actuator mount. The actuator itself is this actuator from Progressive Automations. It can handle a force of 39 pounds, which is more than enough for what we need. Several travel options are offered for this unit, and we will be using the one that has 1 inch of travel. We actually only need 3/4 inches of travel, but a 3/4 inch travel option does not exist. So to account for this extra 1/4 inch, our mount will have a 1/4 inch slot in the mount for that extra travel. So here's a look at the mount design. We will have a simple bent plate that bolts to the crossmember at the diff connection bolt, along with a second smaller bent plate welded to the larger bent plate that forms a fork for the actuator to connect to. The ends of both of these bent plates will have the slotted hole for the actuator connection at this end. At the other end of the actuator, we will have 2 small plates that make the connection from the actuator to the park lock lever. So with the parts ordered and delivered, we can now weld the 2 bent plates that form the fork together. And now with the part painted, we can go ahead and install. Note that prior to painting, I eased the edges of the fork to prevent the wider portion of the actuator body from getting hung up on the edges of the fork. Here we already have the small plates installed on the actuator, and now are placing the final bolt onto the actuator lever. Going in next is the main portion of the mount bolted to the crossmember at the diff mount bolt. We'll keep this loose for now until we make the connection at the actuator to ensure that we have the orientation right. And now here is the bolt for the connection at the actuator, and I am placing some small washers in here in order to center the actuator rod in the fork. The fork needed to be kept wider than the width of the actuator rod because it needs to accept a portion of the actuator body which is wider. And now we can tighten the mounting bolt. You can see that I placed an Amphenol connector on the end of the actuator whip, which will ultimately receive the mating connector on the body harness. We will temporarily apply power to test the function. And now reversing the polarity, which will ultimately be handled with our park drive reverse switch and associated double pole, double throw relay that was covered in episode 9. Okay, so with the rear installed, we can now handle the front for the drive disconnect. And this one is a little more complex and is also a little more difficult to install from below the vehicle. Here at the front gearbox, you can see the drive disconnect, which was installed in episode 11. This disconnect is used to keep the front motor disconnected from the front wheels when in two-wheel drive and connect the motor to the wheels when in four-wheel drive. This disconnect is pushed back and forth via a fork that sits within the channel in the disconnect, and normally this fork shifts back and forth via a carriage that swings the arm rotationally via an extension on the fork, and is also usually controlled via a manual cable. However, I want this operated automatically via an actuator that is switched via my four-wheel drive button, and in conjunction with this, I will have this fork slide orthogonally in lieu of a rotational movement from the fork extension. As with the rear park lock actuator, I am using the same actuator from Progressive Automations, except that this drive disconnect only requires a ½ inch of travel. As with the rear, this actuator can handle a force of 39 pounds, which is way more than enough for what we need. Similar to the rear, we will be using the chassis crossmember at the front for the actuator to push off of. The disconnect fork itself will be connected to a bent plate that will slide within a carriage that is suspended from the secondary battery box platform. You'll recall that we drilled holes in the platform ribs when we constructed this platform for the attachment of this carriage, which you can see in episode 13. The carriage will be a U-shaped part that is bolted to the 4 holes in the ribs. This needs to be handled as 2 L-shaped parts which will be welded together since the bending cannot be formed on this U-shape. This carriage will drop down to a height that is just below our actuator mounting point at the crossmember, but higher than the disconnect fork. We'll give the carriage slotted holes at the mounting points to give us some tolerance for mounting in the front-back direction, and also some tolerance for the actual locations of the holes in the ribs. The fork slide will actually be made up of 3 components. First is the basic bent plate slide here, and then we will also have another separate plate that will be welded to the top of the fork. This will allow us to keep the fork and slide separate and have them bolt together. This is necessary in order to make the installation, which we will cover more in a minute. Lastly, there is this angle, which is what the actuator will push against. This is connected to the main slide via a bolt through a slotted opening, which allows us tolerance to create the correct distance between the crossmember and this angle. You'll also note this slotted opening in the carriage, which allows this sliding connection to be made without getting hung up on the fixed carriage. I originally thought that I would have the slide connect down to the carriage via a bolt through a slotted connection, but decided instead to provide these rails and closure pieces, which I think provides for a smoother slide. So with the parts ordered and delivered, we can now weld up the parts, starting with the 2 U-shaped carriage parts for the U. And next we will weld in the slide rails. Followed by the slide rail covers that keep the slide from lifting. With the slide rails in and the slide operating smoothly, we will now weld the attachment plate to the fork. This is the plate that will bolt to the slide and is needed in lieu of a direct welded connection to the slide so that the slide can be slid into place, which requires front-back movement to install, and the fork can separately be put into place, which requires up-down movement to install, and then the 2 can be bolted together. Here now is the drilling and tapping of the holes at the fork plate and slide to make this connection. The fork plate gets untapped through bolt holes. and the slide gets tapped holes. The through holes were first drilled on the fork plate, and then these holes were transferred onto the slide with these components temporarily installed in the vehicle to get the alignment right. You can see that the bottom leg on the slide was left long, and now with the two parts attached to each other, we can mark and remove the excess portion of the leg on the slide so that it does not conflict with the drive disconnect. Here under the vehicle now, I'm drilling and tapping the hole for the actuator bracket connection. And now for the related bracket at the other end of the actuator on the slide angle. Okay, so with the parts painted, I'll show you how the remaining parts go together, since this will be difficult to see under the vehicle once installed. First, here is the slide inserted into the carriage, followed by the slide angle that the actuator will push and pull against, and now the fork with the attachment plate that will attach to the slide. Before installing in the vehicle, we will connect a few parts on the bench where it is easier to do, rather than under the vehicle. Here's the actuator mount bracket going onto the slide angle. This bracket was not used with our rear actuator since we mounted differently for that, but these brackets did come with the actuators. Next, the actuator can be connected to this bracket. Under the vehicle now, and much of this will be tough to see, but I am now installing that same actuator and slide angle assembly to the actuator mount bracket that is installed at the chassis crossmember. Note that I have the actuator in the collapsed position, which is the position when the drive disconnect is in the forward or connected position, which is the position that the drive disconnect is currently in. Next, we will get the support carriage into place, and this will not yet be bolted down tightly. Next, the slide can be inserted. Now the fork can be placed into the disconnect channel and then bolted to the slide. With the disconnect in the correct position, matching the actuator's collapse position, we can now install and tighten the bolt that connects the slide angle to the slide, and also tighten the bolts for the carriage attachment to the support platform ribs. And now here's the functioning of this actuator and disconnect, which will ultimately be controlled by the four-wheel drive switch and its associated double pole, double throw relay. Okay, so that's it for now. Next time we will hopefully have all of our EV systems sorted out and review all of the issues encountered and the functional testing of the systems. See you next time.